Expectation. What is the expectation of a random variable? You call it expectation or expected value, or sometimes you also refer to it as mean. So expectation is a measure of central tendency of a random variable. So how do you measure central tendency? It is done by taking the weighted average of the values this random variable can take. So let us say you have a random variable which is x. Let us say x can take different values 1, 2, 3, 4, etc. Now, if you take average, let's say there are only 4 values. How would you take average normally? Simply you would do 1 plus 2 plus 3 plus 4 whole divided by total number of values, that is 4. This is your average. But what you want is x may take these values with some probabilities. That is, if you have a total of, let's say, 100 trials, out of these 100 trials, x may take, let's say, value 1 with some probability of 50%, which means 50 times out of 100 it may take value 1, which means this average value would not be a correct representation of the expected value of x. That is, when you say x, what should be a average or expected value? If you simply take average, it won't always be the right measure. I'll show you how. See, first of all, I'll give you the formula for expectation and then we'll explain this. Expectation of a random variable x. It is found by this: expectation of x is equal to, how would you do it? You would sum over all the values of x into p of x, where p of x is the probability of x taking the value small x. That is, probability of x taking the value small x. This is what I referred as p of x. Okay, p of small x means probability of the random variable x taking the value small x. Let us take a real example and understand this concept. That way it will be clearly stamped into your mind. Let us say you have movie reviews. You see Google reviews of movies, right? You can give either 5-star rating, 4-star rating, 3-star, 2-star or 1-star. So if you simply take average of these ratings, what would you get? You would get 5 plus, 4 plus, 3 plus, 2 plus 1 whole divided by 5. So this will turn out to be 3. So this would mean the average, let's say this is your random variable. It can take values 1, 2, 3, 4 and 5. Random variable x denotes the rating that the movie gets. So average value is 3. But let us say you are talking about some particular movie and you want to find the expected value. So let us say for this particular movie, your users are expected to, let's say, choose 5-star 80% of the times. Provide a 5-star rating for this movie 80% of the times. And let's say 4-star 10% of the times, maybe 3-star 5%, and 2-star may be given by, let's say, 3% of the users, and 1-star by, let's say, 2% of the users. In this case, if I tell you that 3 is the average rating, would it be fair to say that? No, right? Because most of the users are choosing 5-star, which means the expected value of the rating for this movie should be a bit biased towards 5, and it should not stay exactly in the middle, that is in 3 value. Because more users are choosing 5-star, the value should be biased a bit towards 5-star, which you won't find if you simply take the average, because average turned out to be 3. So here the concept of expected value or expectation comes into picture. How do you find it? I told you, you summation over all the values of x into p of x. This is how you find expected value. So let us use this formula here. How would you do this? Expected value is equal to expected value of x is x into p of x. Let's say 5-star, 5 into, what is the probability of 5? 80%, which means 80 by 100, plus what is the next x? It is 4. 4 happens 10% of the times, which means 10 by 100, plus 3 happens how many times? 5%, 5 by 100, right? 5 by 100, plus rating of 2 is given how many times? 3%, which is 3 by 100, plus that is 3 by 100 is the probability. You understood that, right? And 1 rating is given 2 2% of the times, 2 by 100. So if you do this, 5 into 80, it is 400, plus 4 into 10 is 40, plus 3 into 5 is 15, plus 2 into 3 is 6, plus 1 into 2 is 2, whole divided by 100, right? So this will turn out to be 440, 455, 461 and 463. So this will be 463 divided by 100. So what will this value turn out to be? 463 by 100, that is 4.63. This means the expected rating for this movie is 4.63, and this seems very logical because most of the users are giving it a 5-star rating and there are very less users, only 2% gave it a 1-star, which means the expected value of the movie rating for this particular movie is 4.63, which is very logical. So this is the concept of expected value. Let us also see when this expected value will be same as average. Expected value will be same as average if the probability of all the values is same. That is, let us say a user would rank all these with the same probability. Let's say 20% chances of giving 5-star, 20% chances of giving 4-star, same 20% with 3, 2 and 1. In that case, you don't have to consider probabilities because all are equally likely occurrences. The random variable x can take any of these values equally likely. So in such cases, expectation is same as simply taking the average. And one more case, it is when you take sample points from a set. Let us say it is the same set of movie ratings. And let us say the previous percentages that we use that hold, that is 80% for 5 and 2% for 1. If this holds, and instead of simply considering each value once, let us say you are considering the actual rating that is given. That is, you have complete data set. That is, you have 5, 5, 5, 2, 4, 5, etc. If this is the total data set that you are having, in that case, what happens is if you take a total of 100 ratings, automatically in your total data, 80 of those 100 would be value 5, right? Similarly, only 2 out of those 100 will be value 1, which means automatically these probabilities are taken into consideration if you take sample data. If you sample some points from this data set, then automatically this is taken into consideration. In that case, you can simply take average of all those points. That is, you can add all the 100 points, 5 plus 3 plus 5 plus 5 plus 2 plus whatever be the ratings, whole divided by 100, all the 100 values divided by 100. So in this case, you can simply take average and you will get expected value. But if you are considering the value provided to random variable, that is, you have a discrete random variable x, it can take values 1, 2, 3, 4, 5. Then you can't simply take average of all the possible values. Instead, you have to see what is the probability of x taking each of these values. That is considered to be the weight of those particular values. And then you have to take the weighted average. And that is done by taking x into p of x, and this you have to sum over all the values of x. Understood, right? Let us now consider what would happen if instead of a discrete random variable we choose a continuous random variable. In terms of continuous random variable, what happens? This would not take values like 1, 2 and 3. Instead, it would take values in a range, let's say range of 0 to 2. You have to identify what is the chances of this random variable taking a value in between 0 and 2. So here you don't have discrete values. We already discussed previously about this. So in this case, if you want to find expectation where x is a continuous random variable, this time you can't do this. That is, if you want to sum x into p of x, this should take discrete values x. Then only you can do sum over x into p of x. Here you don't have discrete values. So instead, what would you do? You would take integral of x into p of x dx. This would give you the expectation for that range. That is, if you want to see expectation of the particular random variable which varies from 0 to 2, then you can integrate from 0 to 2, right? This is the other concept. And we already talked about when it would be simply averages. If it is simply averages, then what you can do? You can, let's say there are n points in total, then you can do 1 by n sigma I equal to 1 to n, and you can do xi. right? This is how you take normal average without weighted average. So this is done in case all the outcomes are equally likely.